projectile thrown from the ground. Projectile thrown from the ground. This is the ground or the horizontal direction. A projectile of mass m is thrown from the point O on the ground obliquely, and the projectile describes this type of parabolic trajectory or parabolic path. Initial velocity of projection. Now the projectile strikes the ground at this point, and we can consider the horizontal direction as x-axis. Now the initial velocity of projection is u. U is the initial velocity of projection along this direction, and we can consider two rectangular components or two mutually perpendicular components of velocity of projection u. Uy is a vertical component. U makes an angle theta. U makes an angle theta with the horizontal or with the ground. Makes an angle theta with the ground. In this case, the horizontal component of velocity is ux, which is equal to u cos theta, and the vertical component uy is equal u sin theta. We can extend the vertical direction. Oy is the vertical axis or direction. When the projectile reaches at the highest point A, this is what the position of the projectile at the highest point A. A is the highest point at which the projectile will have a tangential velocity. From the highest point A, we can draw a normal AN. AN is the normal drawn from the highest point A on the ground. This is the normal AN, which is drawn from the highest point A on the ground. And here AN is the maximum height H max. At the highest point A, the projectile has the tangential velocity. At the highest point A, the projectile has the velocity V along the tangent AX1. At the highest point A, the projectile has a velocity V along the tangent AX1. H max, which is equal to N, is the maximum height. At the point O, time t is equal to 0. At the point N, time t is equal to capital T1, which is the time of ascent. That means time taken by the projectile to move from O to A. At the point B, the projectile strikes the ground with the velocity V prime. At the point B, the projectile strikes the ground with the velocity V prime along this direction. V prime is the velocity with which the projectile strikes the ground. The projectile strikes the ground at the point B with the velocity V prime at an angle phi with the horizontal. Phi is the angle with which the projectile strikes the ground at the point B. Now we can consider the two rectangular components or two mutually perpendicular components of the velocity V prime of the projectile at the point B. Here Vy prime is the rectangular component which acts vertically downwards. Here Vy prime is the rectangular component of V prime in vertically downward direction at the point B, and also we can denote the horizontal component of V prime. Here the horizontal component of the final velocity V prime at the point B will be V prime x or Vx prime. Here we can draw a rectangle or parallelogram taking v prime or final velocity v prime as the diagonal of this rectangle. Here we can draw a rectangle taking v prime as diagonal and other two rectangular components as the two adjacent sides. Vx prime is the horizontal component of final velocity v prime along the horizontal direction such that Vx prime is equal to v prime cos phi and Vy prime, that is a vertical component, is equal v prime sin phi, is equal v prime sin phi. These are the two mutually perpendicular rectangular components of final velocity v prime at the point B. Now we can consider the two rectangular components of velocity v at the highest point A. Vy is the rectangular component of v in vertically upward direction at the highest point A, and Vy is equal to v cos 90 degree because Vy is perpendicular to v. That means angle between Vy and v is 90 degree. That's why Vy is equal v cos 90 degree. Similarly, we can consider the rectangular component of the velocity v at the highest point A in the horizontal direction. V is along the tangent ax2 at the highest point, and we can consider the rectangular component of v in the same direction or in the horizontal direction. Now v is along the tangent ax2 and vx is the rectangular component of v in the same direction or in the horizontal direction. Here Vx is parallel to V and Vy rectangular component in vertical direction, Vy is perpendicular to V. As Vx is parallel to V, that's why Vx is equal to V cos 0 degree, which is equal to V because cos 0 degree is 1. Now Vx is parallel to V. As this rectangular component Vx is parallel to V, that's why Vx is equal to V cos 0 degree. Angle between Vx and V will be 0 degree. Now the horizontal component of velocity of a projectile remains constant. The horizontal component of velocity of a projectile remains constant because there is no component of acceleration due to gravity in the horizontal direction, because there is no component of acceleration due to gravity in the horizontal direction. That's why ux is equal to vx is equal to vx prime. Ux is the horizontal component of velocity of the projectile at the point O, that is at the point of projection. Vx is the horizontal component of velocity at the highest point A, and Vx prime is the horizontal component of velocity at the point B at which the projectile strikes the ground. Therefore, ux is equal vx is equal vx prime. That means horizontal component of velocity of projectile remains constant because there is no component of acceleration due to gravity in the horizontal direction. Also, the vertical component of velocity of the projectile. The vertical component of velocity of the projectile decreases from the point O to A. From the point O to A with the magnitude of uy equal u sin theta 2. Vy equal 0. Uy equal u sin theta is the vertical component of velocity of the projectile at the point O, and it decreases to 0, or it decreases to Vy equal 0 at the highest point A. At the highest point A. And it increases from the point A to B with the magnitude Vy equal 0 to with the magnitude Vy equals 0 to Vy prime equal V prime sine phi. At the point B, the vertical component Vy prime is equal to V prime sine phi, where V prime makes an angle phi with the horizontal. Now we have to find the expression of time of ascent. Let a projectile of mass m let a projectile of mass m be thrown with the initial velocity u at an angle of theta with the horizontal direction from the point O on the ground. The projectile reaches highest point A. The projectile reaches to the highest point A from the point of projection O in time capital T1, which is known as the time of ascent, for the projectile. T1 is the time of ascent. Now at the point n, t is equal to capital T1, which is the time of ascent, and which is the time taken by the projectile to move from the point O to highest point A. Now in the diagram we can write down three equations of motion, which is v equal u plus at, s equal ut plus half at square, and v square equal u square plus 2a dot s. V square equal u square plus 2a dot s. These are the three equations of motion, and we have to use any one of the three equations. Here we have to use that equation v equal u plus at to find time of ascent. Hence we can write, using the equation v equal u plus at from the point O to A in vertically upward direction, we get Vy will be equal, Vy will be equal Uy plus GT1, Uy minus GT1, not plus GT1, it should be minus GT1. Now using V equal U plus 18 vertically upward direction from the point O to A, acceleration A is minus G and V is equal to Vy, and initial velocity u equal to uy, a is equal to minus g, and the time small t is equal capital T1. Therefore, now vertical component at the highest point A is Vy, which is equal to 0. So we can write 0 equal u sin theta minus g T1, or g T1 is equal u sin theta. Therefore, T1 is equal to u sin theta divided by small g. T1 equal u sin theta divided by small g. That is the time of ascent. Of the projectile thrown from the ground. T1 is equal u sin theta divided by g, which is the time of ascent of the projectile from the ground, and therefore T1 is the time of ascent to move. T1 is the time of ascent to move from the point O to A by the projectile. Here T1 is the time of ascent, or time taken by the projectile to move from the point O to A, that is from the point of projection to the highest point A, which is known as time of ascent. In this case, we have to find the expression of maximum height. At the highest point A, the projectile attains the maximum height h max. Therefore, h max equal question mark. Using which equation between the 2 points O and A, we can find the expression of h max. Using which equation from the point O to A, or between the point O to A in vertically upward direction. So we have three equations of motion. One is v equal u plus at, another is s equal ut plus half at square. Third one is v square equal u square plus 2a dot s. Here we have to use either s equal ut plus half at square or v square equal u square plus 2a dot s. Here we have to use the equation v square equal u square plus 2a dot s. We get vy square equal uy square plus 2 under bracket minus g h max minus g h max, or comma 0 equal u sin theta whole square minus 2g h max, or comma 2g h max is equal to u square sin square theta, u square sin square theta. Therefore, h max is equal u square sin square theta divided by 2g. H max is equal u square sin square theta divided by 2g, which is the maximum height, attained by the projectile, at the highest point A. Now we have to find the expression of time of descent. Time of descent of the projectile, that is time taken by the projectile to move from the highest point A to the point B at which the projectile strikes the ground during downward motion. Let T2 be the time of descent. Time of descent in which T2 be the time of descent in which the projectile travels, or moves from the highest point A to B at which the projectile strikes the ground, in which the projectile moves from the highest point A, to the lowest point B, at which the projectile or it strikes the ground with the final velocity v prime at an angle phi with the ground or with the horizontal. So T2 is the time in which the projectile moves from the highest point A to the point B at which it strikes the ground with the velocity v prime. So here T2 is the time of descent. T2 is the time of descent in the diagram taken by the projectile to move from the point A to B. This is the ground and at the point B, v prime is the final velocity with which the projectile strikes the ground at an angle phi with the horizontal direction. Now we have to find the expression of time of descent, that is the expression of T2, using the equation s equal ut plus half at square. Using the equation s equal ut plus half at square between the 2 points A and B, that is between the highest point A and the point B at which the projectile strikes the ground in the vertically downward direction. We get H max is equal to minus Vy T2 plus half under bracket plus G T2 square using the equation S equal ut plus half at square between the 2 points A and B in vertically downward direction. The vertical displacement H max will be equal to minus Vyt plus half Gt square. Minus Vyt plus half Gt square at the highest point A. Vertical component is Vy, which is in the vertically downward direction, but we are using the equation in vertically downward direction. That's why initial velocity Uy will be minus Vy. Displacement S is plus H max. U is minus Vy because Vy is in the vertically upward direction, and we are using this equation in vertically downward direction. Acceleration A is plus G if we consider the equation in vertically downward direction, equal minus V cos 90 degree T2 plus half G T2 square. Cos 90 degree is 0. So cos 90 degree is 0. That's why we can write H max as equal half G T2 square because cos 90 degree is 0. Or comma T2 is equal root over 2 by G into H max, 2 by G into H max. T2 is the time of descent, that is the time taken by the projectile to move from A to B. Now T2 will be equal, T2 is equal root over 2 by G u square sine square theta divided by 2g. Putting the expression of maximum height h max here, now we know that the maximum height attained by the projectile is h max, which is equal to u square sine square theta divided by 2g. So at the highest point, the projectile attains the maximum height h max, and h max has the expression u square sine square theta divided by 2g, or comma t2 is equal, or comma t2 is equal u square sine square theta divided by g square Finally, we get t2 as equal u sine theta divided by small g. T2 is equal u sine theta divided by g. That is the time of descent. T2 is equal u sine theta divided by small g. That is the time of descent of the projectile which was thrown from the ground at an angle theta with the ground or with the horizontal. T2 is equal to u sine theta divided by g, which is the time of descent of the projectile. Time of descent of the projectile. Again, time of ascent. T1 is equal u sine theta divided by g. T1 is equal u sine theta divided by g. That is the time of ascent of the projectile. T1 is equal to u sine theta divided by g, which was time of ascent or time taken by the projectile to move from the point O to highest point A. Therefore, T1 is equal to T2. T1 is equal to T2, that means time of ascent is numerically equal to time of descent. Time taken by the projectile to move from the point A to highest point A will be equal to the time taken by the projectile to move from highest point to the lowest point B. Now T1 is the time taken by the projectile to move from the point O to A, and T2 is the time of descent, which is time taken by the projectile to move from the point A to B. As T1 is equal to T2, this parabolic trajectory or path, the path will be symmetric. That means the left hand side configuration and right hand side configuration will be symmetrical to each other. That means the parabolic trajectory is symmetric for the motion of the projectile. Now we have to find the expression of time of flight at the point B. Time t is equal to t1 plus t2, which is equal to capital T. Therefore, capital T is the time of flight, which is equal to 2t1 as t1 equal to t2. So finally we get capital T as equal to u sine theta divided by g, which is the time of flight. Now we have to find the expression of horizontal range r of the projectile. R is the horizontal displacement of the projectile when the projectile describes parabolic path, and here r is the horizontal range. Using the equation s equal ut plus half at square between the 2 points O to B or from O to B in the horizontal direction, from for the motion of the projectile using the equation S equal ut plus half at square from the point O to B in the horizontal direction. For the motion of the projectile we get R equal ux capital T plus half g cos 90 degree t square equal uxt plus half 0 t square, because g cos 90 degree is 0, as cos 90 degree equal 0. Now at the point A, or at the highest point A, the projectile has a velocity v along the tangent ax1. The vertical component of velocity v is vy, which is equal to v cos 90 degree, which will be equal 0. Therefore, r is equal to ux into t plus 0. Therefore, r is equal to ux into capital T, where capital T is the time of flight. Therefore, r equal ux dot capital T equal u cos theta into u sin theta divided by small g, where capital T is the time of flight, which is equal to 2u sin theta divided by g. Capital T is equal to 2u sin theta divided by g, which is the time of flight, therefore we get u square 2 sin theta cos theta divided by g, u square 2 sin theta cos theta divided by g. Therefore we get r as equal u square 2 sin theta cos theta divided by g. Finally we get capital R as equal u square sin 2 theta divided by g. R as equal u square sin 2 theta divided by small g, which is the horizontal range, of the projectile when a projectile is thrown from the ground.